Okay, we're in Module 8, and we are looking at this first success criteria right now. We're going to be able to use proper vocabulary for angles formed by lines and transversals. And so we want to really make sure you guys know all these vocab words that are down here. That is our learning target today, is as we go through this stuff here. So, excuse me, as we go through this, again, we're just going to go through a lot of these. Some of these are pretty simple, and I think these are pretty quick. First off, you guys need to know what a line is. Guys, a line is, again, a straight path that goes forever in both directions. If it has arrows, if it has dots on it, we call that a line segment. So this is just a line, and then we call this a line segment on the right. So just to give you a heads up, we're going to be dealing with lines that go forever, so that's how we're going to be looking at. If we look at intersection, that's where two lines intersect, okay? So this would be a point of intersection that's right there on the dot that I just drew. That would be considered, again, where two or more lines. And again, you can have multiple intersection points. Like if I have another, let's say I have another line here, there's an intersection point, and if these aren't, these are probably going to end up intersecting as well. So we can have a lot of different intersection points. Okay, parallel. These are lines that are the same distance apart and never touch. So if I have a perfect drawing here, I would have these two lines that are the same distance apart the whole time, and they're never going to intersect as they go. So those are those parallel lines. Okay? And then the opposite of that is perpendicular. These are going to cross, but they're going to perfectly cross at a 90-degree angle, or what we call a right angle. So they'll be straight up and down. Again, as I put my arrows on here, this is going to form this right angle, or a 90 degree is what we consider to be a perpendicular intersection. So parallel never intersect, perpendicular intersect at a right angle every single time. And as a matter of fact, it makes all these intersections 90, okay? All right, here's the big stuff we're going to look at quite a bit. So a transversal is a line that crosses two or more lines. Okay, so if I have these two lines here, this line right here is what we consider to be a transversal. And we'll just label it T, but it has to intersect at least two lines. So it's intersected both L and M here, or whatever those lines are called. And so that would be a transversal. This line with the T on it is going to be a transversal. Vertical angles, these are opposite angles. Again, opposite angles made with two lines, and they are always equal. So these two lines that intersect, it doesn't really matter where. These two angles right here that I'm labeling right here and here, those are considered to be vertical angles. And they are always going to be equal. Again, that word always is important going forward in this short unit. So every single time that we see vertical angles, they're going to be equal. Same thing with these two angles. They're vertical, and they're going to be equal too as well. So that happens at every intersection that I have. Those angles that are vertical are going to be equal to each other. I then have linear pairs. Okay, so these linear pairs are two angles that are right next to each other that make a straight line, and they're going to always add up to 180 degrees. So if I have a line here and a line here, this is my straight line, and this angle are right next to each other, and they're going to add up to 180 degrees. These are linear angles. Again, the two that are right next to you, along with the two that are below as well, those are going to be linear to each other. There's only two, they're pairs, and so they're going to form this straight line, and that's what we consider to be a linear pair. Okay, now we get back into some things that you guys have probably seen before, but let's make sure you guys are good here. So alternating interior angles are angles on opposite sides of the transversal, so we're going to need that word again, in parallel lines. And in parallel lines, they're equal, okay? So alternating interior angles don't, I mean, if you have lines that are parallel, they're going to be equal, but if you just have, let's just draw this diagram. So I've got two lines here, and I've got transversal here. Alternating interior angles are going to be this angle with the dot and this angle with the dot. So from here to here. And when L and M are parallel, and we'll talk more about this in the next unit, they are equal to each other. So again, this angle and this angle are alternating interior angles. Okay? If I look at alternating exterior angle, it's pretty similar definition, just the outside. So again, I'm going to have this diagram here where I have a transversal and I have L and M. Again, they don't necessarily have to be parallel for you to have alternating exterior angles, but when they are, they're equal. And we'll talk more about that. That would be this angle and this angle. So they're on opposite sides of the transversal and they're outside. So interior inside of the two lines, exterior on the outside of the two lines, the L and M. Okay? And again, yes, it could be these two with the X's in them too. Those could be alternating exterior angles. So you need to be able to identify them right now more than anything else. Okay? Corresponding angles are angles on the same position at different crossings. And again, they are equal when the lines are parallel, but we'll focus more on that later. So if I'm looking here, and let's say I've got this angle, this is in the upper left hand of this intersection. If I go back down to this intersection, that spot's in the upper left. So those two would be corresponding. This would be corresponding with this because it's upper right of the intersection. Okay? That lower right and that lower right would be corresponding. And then, yes, I could have these lower left ones that would be as well. So we have 4 pairs of corresponding angles within our diagram that we've got for this one. Okay? Think about position. Position is really important at the intersection. So upper left, upper right, lower left, lower right. And they're going to be a pair of angles. Okay? Consecutive interior angles. Well, if you know what alternating interior angles, you should know consecutive. They're going to be on the same side of that transversal. And they're going to be interior. So they have to be inside of the angles. So if I take this angle, the consecutive interior is going to be right here on that same side. Okay? All right, couple other ideas here. Just some terminology. Congruent means the same shape and same size, so they're going to be essentially equal to each other. So if I have an angle that's 20 degrees and I have another angle that's 20 degrees, they're congruent. If I have a shape that's the certain shape and I have another one that's the same, it's going to be congruent to each other because they equal to each other. Okay? Supplementary means that the two angles add up to 180 degrees. So I could have an angle that's 100 and one that's 80. Those two added together are 180. I could have one that is 70 and then another angle that's 110. When I add them, those are supplementary because they add up to 180. And then complementary, these are two angles that will add up to 90. So I could have something that's 30 and 60. Those two would add up to 90. Those are complementary. And we're going to focus a ton on congruent and a ton on supplementary because when all my lines like L and M are parallel, all my angles end up being supplementary or congruent quite often, and every once in a while they become complementary. Okay? So, know the positions, not so much the rules right now. I need you to know, the positioning, not so much the rules right now. Okay? All right. we will get more into the rules later. We'll see you later.